Welcome back to your favorite YouTube channel, Planner Studies, and we'll be continuing on the Calculus 1 series, and this is lesson 2, evaluating limits. But before we begin, I'd like to encourage you to subscribe to our channel if you are new to this channel, and also to like the video and share the link with your classmates and friends who can also benefit from this fabulous channel. With all that aside, let's get into what we have to learn from this video. We're looking at lesson 2, how to evaluate limits, and this is the part 2. And if you haven't watched the part 1, I do encourage you to watch the part 1 of these 2 videos, part 1 and part 2. So we are continuing from where we stopped in part 1. We stopped at example 5, so we'll be we stopped at example 4, so we'll be continuing with example 5 in this video. So example 5 asked us to evaluate this limit, the limit of x squared minus square root of x divided by square root of x minus 1 as x approaches 1. Now this has a lot of square roots. It may look challenging at first, but with a proper strategy, with a proper plan, we can actually solve it. So let's get right into business as we solve. So this is the question. It came in this form. So of course, at first we want to just use the substitution method to just substitute x for 1. Whenever we see x, we put in 1. So now we've done that, we have 1 squared minus square root of 1 divided by square root of 1 minus 1. We then get 1 minus 1 divided by 1 minus 1. 1 squared is 1, square root of 1 is 1, square root of 1 is 1 again, and this is the 1 that we have there. So we have 1 minus 1, which is 0, and 1 minus 1, which is 0 again. So we have an indeterminate form, 0 over 0. This is indeterminate, as we have already seen in the previous video. We dealt with, I think, 2 examples involving indeterminate forms. So how do we then solve it? We have to come up with another strategy in order to solve a problem like this, as we have been doing. Now we're going to take a new look at the problem that we have, this question, and we are going to see how we can at least simplify it. So we notice the square roots that we have here, square root of x, square root of x. And we can make our job easier if we replace, the essential thing here is that the square root of x is just another power of x. It's x to the power of something. And we're talking about x to the power of 1 over 2. If you didn't know, square root of x is actually equal to x to the power of 1 over 2. And it means that we can actually take square root of x to be a power of x. Now, to further clarify what I'm trying to say, we can make the substitution u is equal to square root of x, as we say let u be equal to square root of x. Now, if this happens, it means we can see that x squared actually by default is equal to square root of x all squared. As in the squared, you square the square root of x the first time and square it again the second time. So you're squaring twice. Now, if you notice, the inner square, the square of the square root of x is x, because the square root will be the square root, so you have x from this first part here. And then when you now introduce the second square, you have x squared, so x squared, and that equals to x squared. So we've proven that, for what we can see here, x squared is just equal to the square root of x to power 4. X squared is just equal to the square root of x to power 4. From the law of indices, you can multiply these 2 powers, 2 times 2, and you get 4. So we have x squared being equal to the square root of x to power 4. And since we said that u is equal to square root of x it means that x squared is equal to u to the power 4. So the square root of x is just u. So we have u to the power 4. So we have two substitutions here. X is equal to u to the power x squared is equal to u to the power 4, and square root of x is equal to u. We are going to use these two to evaluate this limit, to simplify the limit. So now in our question, wherever we see x squared, we replace it with u to the power 4, and wherever we see square root of x, we replace it with u. And once we do that, we have what we are seeing in front of us, u to the power 4 minus u divided by u minus 1. The limit here still remains the same, limit as x approaches 1, but we are trying to view the function in a different way so it will be easier for us to solve it. Now, we can now simplify by factorizing. That's the first thing that comes into our mind because we see something common at the numerator. This is u to the power 4, this is u. So u is common between u to the power 4 and u. So why not just factorize? U is common. So once we take out u from u4, u to the power 4, we are left with u to the power 3. And once we take out u from u, we are left with 1. So we have u multiplied by u cubed minus 1 divided by u minus 1. Now there is another important thing I want to state here is that you can check if a particular function is divisible by a function of the form of this type, like this u minus 1. We can actually check if this can be divided by u minus 1. So the thing is that in generally speaking now, a function f of x can be divided by another function that's of this form, x minus a. That means that you can divide this function by this function without a remainder. That means you have a remainder of 0. If so, f of x is divisible by x minus a function of this form x minus a, if f of a is equal to 0. So the explanation here is that f of x is divisible by any function of the form x minus a if f of a is equal to 0. That means that you just, the number you have here without the minus sign, now take note, the number you have here, you just put it into the function. So you substitute it into the function. And if you get 0, it means that your function is divisible by a function of this form x minus a. By x minus a, I mean your function can be of the form x minus 1, x minus 2, x plus 3, which in this case is similar to x minus 3 in this case of x plus 3. So it is minus 3 that will be substituted into the function. If it's a plus, then you're going to use minus that number. If you have a plus, minus that number. Because x plus 3 is the same thing as x minus 3. So I'm going to use minus 3 in this case. But let's look at what we have. We have u minus 1. So u minus 1. It doesn't matter if it's x and u are still variables. So it's the same thing as having x minus 1. You can think of it that way. U minus 1. So if I put in 1 into the function I have here, u cubed minus 1, do I get 0? Let's try. We have u cubed minus 1. So 1 cubed minus 1 is equal to 1 minus 1 is equal to 0. It means that this is divisible by this. I can actually divide them. So the thing is, once I divide the two of them, what's my answer? So I'm going to guide you through the process used to divide these two functions. So it's actually very easy, and as you keep on practicing, you get used to it. So we just draw a simple, it's just like long division, but just with a few extras added. So we have u cubed. Now the next thing is a minus 1. So I'm going to leave spaces in between u cubed and minus 1 because the spaces I'm leaving are for the power of the term with the power of 2, the term with the normal power, and also we have the constant. If you want to look at polynomials, cube, squared, to the power of 1, and then the constant. So since the next thing that follows is a constant, it goes to the far extreme end, let's shift it. So we have u minus 1 here. Now, u cubed divided by u is u squared multiplied by u is u cubed. Now, u squared multiplied by minus 1 is minus u squared. So that's why we kept the space there. The term with the power 2, that's why we have left spaces. So the term with the power of 2 has now come in here. So if you notice what I did, I first of all used u cubed to divide u, getting u squared, then u squared multiplied by everything here being multiplied. Both u and minus 1 are being multiplied by u squared. So we get u cubed minus u squared. Now you're going to want to subtract. So we see this is like saying 0 minus u squared. So that's u squared. Minus times minus is plus. So minus u squared then. That would be u squared. U cubed minus u cubed is 0. So that's gone. Now we do the cycle again. Just like we did the first time, we are doing the same thing again. U squared divided by u gives us plus u. The plus u times u is u squared, and plus u times minus 1 is minus u. And then we are off to repeat the cycle again. We're off to do the same thing again. So minus 0 minus u, that's u, of course. U squared minus u squared is 0. So we can bring down this minus 1 because after u, the next thing is a constant term. So u minus 1. So u divided by u is 1 plus 1. And then 1 times u is u. And 1 times minus 1 is minus 1. So we subtract again. Minus 1 minus 1. So we take note of that minus 1 minus 1. So this is minus 1 plus 1, which is 0. So the signs are very important. So 0 and u minus u, of course, is 0. So everything is 0 here. So if this is a way to check your answer, if truly u cubed minus 1 is divisible by u minus 1, you'll have a 0 here. If you have any other number here, then it's not divisible. You have a 0 here, which confirms to us that there is no remainder, because this place here has a remainder. So you have a remainder of 0. So it's divisible. So the thing, what have we done now? We see that when we divide the two of them, when we divide u minus 1 by, or divide u cubed minus 1 by u minus 1, we actually have this u squared plus u plus 1. So now back to our problem. We see that this limit here, the limit as x approaches 1 of u into u cubed minus 1 divided by u minus 1 is equal to the limit as x approaches 1 of the limit of this entire thing. So the limit of as x approaches 1 of u multiplied by u cubed minus 1 divided by u minus 1. We've already done this part here and we've gotten our answer. So this is just equal to the limit as x approaches 1 of u multiplied by the answer we have from here is u squared plus u plus 1. So u squared plus u plus 1. So this is just equal to the limit as x approaches 1 of, so u times u squared, that's u cubed, u times u squared, u times 1, that's u. And if we now try and use, okay, but before that, this is as x approaches 1, and these are u terms, these terms are in u. So we have to use our substitution to change it back. We said that, at the beginning, we said let u be equal to square root of x. At the beginning, we had already declared that u is equal to square root of x. So we change it back, very important, change back. So this is equal to the limit as x approaches 1 of u cubed, which is just equal to the square root of x all cubed, plus u squared, that's the square root of x all squared, plus u, which is the square root of x. So simplifying further, we have limits as x approaches 1 of the square root of x all cubed plus the squared here cannot come with square root, so x plus square root of x. And if we now put in 1, when we put in 1 wherever we see x here, we will have the square root of 1 all cubed plus 1 plus square root of 1. This is still 1 plus 1 plus 1 plus 1, because square root of 1 is 1, 1 cubed is 1, plus 1 plus 1 again, the square root of 1. So 1 plus 1 plus 1 gives us 3. And that is the final answer. 3. 3 is our final answer. Now, right here in front of us is the graph of we've been the function that we found the limit of as x approaches 1. So I'll graph it, and we see that as x approaches 1. So as I'm approaching 1, this is one of the x-axis here. As x approaches 1, either from the left or from the right. As I approach 1 on the graph, I'm getting closer to 1. I approach I approach 3, so I see that I approach 3 there. As I approach 1, I approach 3 either from the left, or even if I come from the right hand side. As I'm approaching 1, the value 1, I'm approaching 3. So that's what the limit means. The value that the value in which the y values approach as the x values get closer and closer to the marked value. That gives us an understanding of the limit. So our next example sees us solve this limit. The limit of x cubed plus 8 divided by x4 minus 16 as x approaches minus 2. Now, in order to tackle this problem, we consider that we just analyze the problem first of all. Okay, we have this limit. So as usual, we always start with the substitution method. But if we do that, we'll just end up with 8, with minus 8, because minus 2, yeah, minus 2 all cubed plus 8 divided by minus 2 to the power of 4 minus 16. So what we're ending up with here is minus 2 all cubed. That's like minus 2 times minus 2 times minus 2. Minus 2 times minus 2 times minus 2. So minus times minus is actually plus. When you look at it, minus times minus is plus, but multiplied by this other minus here gives you a minus. So 3 minuses gives you a minus. So minus 3 all cubed will be minus 2 times 2 times 2 is 8, so minus 8. So minus 8 plus 8 divided by, in this case, we have minus 2 to the power 4. So that would be plus 16, because you have 4 minuses, minus times minus times minus times minus minus times minus is plus times minus again, that's minus, then times minus again is plus. So plus 16, so that's 16 there, minus 16. So we have the 0 over 0 that we've been seeing recently, 0 over 0. But we still wish to solve this, even despite this indeterminate form. So the method we're applying is simplification. Now take a deeper look at the limits. So what do we do? What can we do? From the numerator side, we can't really say anything about the numerator. It's x cubed plus 8. We can't really say much about it. But for the denominator, we can actually say much, because this is in the form of difference of 2 squares. Now, the reason is because this is x4 minus 16. Now, we know that 16 is a perfect square, right? What about x4? x4 is just equal to x squared all squared. So x squared all squared is x4. So that gives it to us. And then 16 is equal to 4 squared. So we can express this as a difference of 2 squares. So we can break the difference of 2 squares down into, we can factorize it. We can break it down. So this is limit as x approaches minus 2 of x cubed plus 8 divided by, this becomes x squared. The first bracket is x squared minus 4. Second bracket is x squared plus 4. So that's how we break it down using this. These are the square roots of x4 and 16. So we just use them to factorize it. One bracket has a minus, the other bracket has plus. So we look again, what can we do? We have x cubed plus 8. Can x cubed plus 8 actually divide x squared minus 4? Let's see that. So basically, this is x squared minus 4. So it's not in the form of x minus a. It's not in that form. So there's not really much we can do because it's not in that form. But then, if we look at this x squared minus 4, we can still get 2 other brackets from it, because it's still a difference of 2 squares. X squared minus 4. X squared, the square root is x, and 4, the square root of 4 is 2. So we can still further break this down. We can still break this down further if we want to get the limit as x approaches minus 2 of x cubed plus 8 divided by x minus 2, x plus 2, x squared plus 4. So this x squared plus 4 is still accompanying, is still there, but then these two are what form your x squared minus 4 coming from. So it has been broken down again, x minus 2, x plus 2, from difference of 2 squares. So we can now see that we do have an x minus 8 term here. Actually, 2x minus 8 terms, if you look at this one, it's x plus 2, which is still the same thing as x minus 2. So we have 2 options there. We have these 2 options to choose from to divide x cubed plus 8. But which one gives us 0? So first of all, x minus 2. So we're using minus 2 here for our function. This is for x plus 2. So minus 2 going in there. If we use minus 2, we have minus 2 all cubed plus 8. So this gives us minus 8 plus 8, which is 0. So yes, this actually gives us 0. So this is the one, meaning that this is the one that we'll use to divide x cubed plus 8. But as for x minus 2, if you had used x minus 2, if you want to compare it to x minus 2 would have given us 2 cubed plus 8. Using 2 now, in this part here, substituting it here, 2 cubed plus 8 is equal to 8 plus 8, which is equal to 16. So it's not 0, so no. So the one that gave us 0 is the one we are using, but as for this one, the answer is no, we are not using it. So it means that x plus 2 is the one we are going to use. So basically, this is what we're doing. We are rewriting the limits as in this form. So it's equal to the limit as x approaches minus 2 of x cubed plus 8 divided by x plus 2 multiplied by, so multiplied by 1 over the remaining brackets that we have. Okay. So now that that's been done, we seek to evaluate in this part here using the same method that we've been using. So x cubed and then plus 8 at the far extreme end, then x plus 2. So x cubed divided by x is x squared multiplied by x is x cubed, x squared multiplied by plus 2 is plus 2x squared. Then we take the difference. So 0, as in nothing here, minus 2x squared gives us minus 2x squared. Then x cubed minus x cubed, 0, that's gone. We seek to divide again, do the cycle again. So minus 2x squared divided by x gives us minus 2x. Then minus 2x multiplied by x gives us minus 2x squared. Minus 2x multiplied by plus 2 gives us minus 4x. So we are making progress, and we seek to subtract. So subtracting, we get 4x minus plus 0 minus 4x. So that gives us plus 4x. Minus times minus is plus. And then, of course, minus 2x squared minus 2x squared. Minus that is plus. So you actually have minus 2x squared plus 2x squared 0 as usual. Then we have our plus 8. And now we seek to go again. 4x divided by x is 4. So I have plus 4 here. Then 4 times x is, of course, 4x. Then 4 times 2 is 8 plus 8. So we see that we are all set to conclude that 4x plus 8 minus 4x plus 8 is 0. So we were right. Our remainder is 0. So this just verifies it, that the remainder is 0. But our main focus is on the answer we get from here. This is what we are using to replace. So this is being replaced by this, is being replaced by this. So replace it with your answer. Just replace it there, and we can now easily solve. So the limit takes us to limit as x approaches minus 2 of x squared minus 2x plus 4 multiplied by 1 divided by x minus 2 x squared plus 4. And we now want to try again by substituting x is equal to -2 inside. Okay, but first of all, we can just make this a little bit more compact by writing this on top. This can just, because this times 1 is still the same, x squared minus 2x plus 4 divided by x minus 2 x squared plus 4. And now we're trying again with the substitution. So wherever we see x, we're replacing it with a -2. So all the x's are being replaced with -2, -2, -2. So here we have -2, -2, and here we have -2 all squared plus 4 as the denominator. -2 all squared plus 4, -2, -2. So x is being replaced by -2. So now we see that this is -2 all squared, which is 4, -2 times -2. That's 4 plus 4 plus 4 divided by -2 minus 2, that's -4. Then -2 all squared plus 4, that would be 4 plus 4, -2 all squared is 4, that's 4 plus 4, we are simplifying. So if you follow this through, we see that the limit that we're trying to solve just gets to 12 over -4 multiplied by 8. So this is 12 over -32, which is the same thing as, so 12 over -32 is the same thing as -12 over 32, which is the same thing as minus. So something is common here. 4 can divide 12, 3. 4 can also divide 32, 8. So -3 over 8. And this is actually a real number, -3 over 8. -3 over 8 is real. And it's actually equal to 0.375 minus 0.375, that is minus 0.375. So we can actually look at the graph just to verify what we are seeing. Now what we have in front of us is the graph of the function that we took the limit of. Okay, so this is the function x cubed plus 8 divided by x to the power 4 minus 16. This is how the graph looks like, but our focus is as we approach -2. As we approach -2, we can see the value is getting closer to -0.3763. That's very close to minus 0.375. So we look at that, -0.3753. So we just get closer to -0.375, which is the same thing as -3 over 8. Even as we approach from the left, we are still approaching -0.37 something, 75 something. So that just verifies our answer that this is the limit of this function. So finally, we are going to our last problem for this video, and in this one we are asked to evaluate the limit as x approaches 7 of 1 over x plus 3 minus 1 over 10 divided by x minus 7. So you have like the difference of two fractions on top, and at the denominator you have x minus 7. We have the function in front of us, the limit in front of us, and we want to evaluate it. As usual, we always try to see if the easiest method can work, the substitution. So whenever I see x, I'm just going to plug in 7. Plugging in 7 wherever I see x gives me this. This is what I obtained when I tried that. And yeah, 1 over 7 plus 3 minus 1 over 10 divided by 7 plus 7. This leaves me with 1 over 10 minus 1 over 10 again. Divided by 7. We all see where this is going to be. 0 over 0 indeterminate form. Now, this is a very common limit. In fact, most of the limit problems we're going to solve are going to be indeterminate, 0 over 0, just to make sure that you go the extra mile to simplify and solve it. So that's why in this video I concentrate mostly on 0 over 0 indeterminate forms, because they are really the most important limits to evaluate. So again, we have to look at what we have in front of us in another light. Try and look for how to simplify the problem. Something should cancel out. That's what we're looking for. Now, the first thing we can look at is we can't help but admire the difference of two fractions at the top. So we actually admire this numerator here, and we kind of get a little bit suspicious about it. Can something actually come out from this? So a way to check if you can get something out of the numerator is to go ahead and simplify it. So what we're going to do is that we are going to evaluate this, simplifying it, as in, this is what we're doing. Limit as x approaches 7. Now for the numerator, we find the LCM of the denominators of these two fractions. The LCM is very easy. Just multiply the two of them together. So that's 10 multiplied by x plus 3. That's your LCM. Very easy. Just multiply them. Then to get what's on the top, we just do this divided by x plus 3. Of course, it's going to be 10. The x plus 3 will cancel and you'll be left with 10. Then this again divided by 10 is going to be x plus 3. So we look at the minus sign here. So we write the minus sign. We write the minus sign first. The minus sign from here is written. And then we have x plus 3. That's the result from dividing 10x plus 3 by 10. So now we proceed to well, we also look at the denominator. We have a denominator. Let's not forget, we have a denominator x minus 7. This is just a numerator. This is the denominator. The numerator has a fraction there, and we can now further simplify the function, the numerator part. Okay, what we have is the limit as x approaches 7 of 10 minus x minus 3 divided by 10 into x plus 3 divided by x minus 7. So this is what we have. I've opened up the brackets that we had. We had the brackets there, which I opened up. Minus times x is minus x. Minus times 3 is minus 3. So minus x minus 3. Both of them are negated. And we have minus x minus 3 over here. We still have the 10x plus 3, and we still have the x minus 7. We move further again to simplify. This is limit as x approaches 7 of. Now for the numerator, it's very easy. This is just minus x. Minus x. 10 minus 3 is 7. Minus x plus 7 divided by 10 into x plus 3 divided by x minus 7. Now, a way of writing this is limit as x approaches 7 of minus x plus 7 divided by 10 into x plus 3 multiplied by 1 over x minus 7. So this is the way you write this. Remember, this is the numerator and this is the denominator. So numerator, and this is your denominator. So of course, the denominator would always have the 1 over. So 1 over this. So this is this times 1 over this. That's what it means. This multiplied by 1 over this is still means the same thing actually. It means the same thing. So we look at something interesting. This is minus x plus 7, and this is x minus 7. They could have cancelled if only they had the same sign. This is minus x. They has the sign opposite to x here, minus. And even 7 here has a sign opposite to 7 here, minus 7. So they cannot cancel as it stands right now. But it doesn't mean that they won't cancel eventually. What I mean is that we can easily correct this by factorizing the numerator, using minus 1 to factorize it, as in you factorize out a minus sign. So this is simple as minus into, so minus x divided by minus x, and 7 divided by minus 1. When I say divided by minus, I mean divided by minus 1. So 7 divided by minus 1 is minus 7. If you notice, when you expand this bracket, you still get minus x plus 7, minus times minus is plus. So just attaching a minus sign and then switching the signs of x and 7. That's all it takes. And you have something identical. You still have 10x plus 3 here, and then multiplied by 1 over x minus 7 over here. Now we see that these can actually cancel out. X minus 7 here can knock off x minus 7 here, so they have cancelled, but we'll have the minus 1 at the numerator. That's the effect, minus 1. There's a minus sign here, so minus times 1 now is minus 1. So we can move further, and we have limit as x approaches 7 of minus 1. Take a note, minus sign here, minus 1 divided by 10 into x plus 3, and we move further. Okay, so we are at a point now that we have simplified to the last. Now we can try the substitution method again. Let's try. Minus 1 divided by 10 into 7 plus 3. Wherever we see x, we replace it with 7. So like here now becomes 7, 7 plus 3. So we have minus 1 over 10 into 10. 7 plus 3 is 10. And this gives us minus 1 over 100, which you can actually go and express as minus 0.01 if you wish to. So that's our answer. This is a real number. So not 0 over 0 now, this is a real number. That's its final answer. So we can actually verify this using the graph. So we have the graph in front of us, and we just scroll over to where we have 7, and we see that as we approach 7, we see minus 0.01043, so on, so on the y coordinate. As we approach it, it gets closer and closer to minus 0.010. So 0.01 is the limit of this function. This is the function here of this function as we approach 7, minus 0.01. This verifies our answer. As we approach it from both ways, we end up getting closer to minus 0.01. In this case, minus 0.010025. So we verify that that is the limit of this function. Minus 0.01 is the limit of this function as we approach 7. So we come to the end of this video. Don't forget to like this video if you have enjoyed what you've listened to, and if it has helped you to understand limits better, you can subscribe to the channel. Share the link with your friends and your classmates. Ask them to join you in this amazing channel, and have a nice day. Stay safe.